Okay, so quickly video lesson on ratio. Question, what do these pairs of numbers have in common? So the pairs of numbers that you can see here, this pair of numbers, this pair, this pair, this pair, this pair. What do they have in common? Right, well the bottom number always appears to be double the one above. The bottom number is always double the one above. And you may also notice that you've got sort of the 1 times table here, 1, 2, 3, 4, 5, and you have the 2 times table here, 2, 4, 6, 8, 10. So the relation, what we're saying here is, I'm just putting the numbers in a table there. The numbers have the same relationship to each other. So the bottom one being double the top, the bottom one being double the top, the bottom one being double the top, bottom one being double the top, and so on. The relationship doesn't change as we move down the table. If you want to go from these numbers to these numbers, we're timesing by 2, timesing by 2, or timesing by 3, timesing by 3. But the relationship, this to this, this to this, this to this, doesn't change as we move along. And the word we have for this is ratio. They have the same. These pairs of numbers, this pair, have the same ratio. Okay, and this is probably the single most important idea in GCSE maths. And the table that I have put these numbers into is you probably call a ratio table, because it just helps to organise your thinking and can be a useful tool for carrying out calculations. Right, here are 4 ratio tables. So we have a ratio here, the one as before, where the bottom number is double the top. So we have that one there. Then we have another ratio table here where the ratio is 2 to 3. So so what happens here? If I double that and double that, the ratio becomes 4 to 6. If I do times 3 and times 3, the ratio becomes 6 to 9. So although these pairs, as we move from here to here and from here to here, although the pairs of numbers look different, they do maintain and keep the same ratio. Here we got 1 to 13. The ratio 1 to 13 is the same as the ratio 2 to 26, which is also the same as 3 to 39 and 4 to 52, and so on. And here are actually the same numbers, but written the other way up, and you'll see why in a moment or two. Now, there are an awful lot of things we can do. The ratio idea is so powerful and common in GCSE maths. So we can use these ratio tables to change the way a ratio looks. So the ratio 2 to 3 is the same as the ratio 4 to 6, and it's the same as 6 to 9, and so on. So if somebody said the ratio of boys to girls in a class was 10 to 15, that would be the same as saying it's 2 to 3. So if we have a ratio that's given us 10 to 15, 10 boys to 15 girls, if we want to say it in a simpler way, we could say 2 to 3. We can use ratio tables to change the way a fraction looks. So you know that a half is the same as 2 quarters, and 2 quarters you'll probably know is the same as 3 sixths, and same as 4 eighths, and same as 5 tenths. So if you have a fraction like 5 tenths and you want to write it in a simpler way, you can divide by 5, and there you are, the fraction is worth the same, but written in a simpler way. If you had the fraction 10 fifteenths here, that fraction 10 fifteenths is the same value as a fraction 2/3. It looks different, but these two fractions where my fingers are, they are worth the same. 2/3 of a piece of cake is the same as 10 fifteenths. So what we're doing there is dividing by 5, dividing by 5. In a similar way, 5 65ths is the same in value as 1/13. Okay, so we can use ratio tables to help us change the way a fraction looks. So for example, if we want to compare, or if you wanted to add a half and 2/3, we could change the half into 3 sixths and the 2/3 into 4 sixths. You can't add a half and 2/3 the way they are, but if you change them both into sixths, change that into 3 sixths and that into 4 sixths, then you can add them. It's easy to add 4 sixths and 3 sixths. That makes 7 sixths. Right. Understand the ratio of boys to girls in a class. So I mentioned that before, I think. If the ratio of boys to girls was 8 to 12, that would be the same as 2 to 3. We can use it for any kind of problems where we want to find if we knew the number of boys to find the number of girls. So if there were 10 boys in the class, there'll be 15 girls. You can use a ratio table to help you solve simple problems like that. Understand the ratio of students to teachers in a school. The ratio of students to teachers in a school. Let's say down the bottom here, let's say you had a school, maybe a small school, where there were 65 students and 5 teachers. 65 students and 5 teachers. That's the same ratio as 13 to 1. So that would be the same. You could say that in that school, the ratio of students to teachers is 13 to 1. 13 to 1. Sometimes we actually just say it as a single number. So what we might say is the ratio of students to teachers is 13. And if we say the ratio of students to teachers is 13, what we should really be saying is the ratio of students to teachers is 13 to 1. But we're sometimes lazy and just say it's 13. Right. The other things that we can do with a ratio table, we can share money in a given ratio. If you want to share money in the ratio 2 to 3, then if you had £25 to share, that's how you would share it. 10 to the first person, 15 to the second person. Working with speed. If somebody cycled 65 miles in 5 hours, if they cycled 65 miles in 5 hours, that would be the same as cycling 13 miles in 1 hour. So their speed would be 13 miles per hour. So you can use it for speed. You can also use a ratio table for multiplying and dividing, for finding unknown lengths in similar shapes, and for working with the sine, cosine and tangent ratios. And that will do for now.